Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the minimum number of arrows to burst balloons problem. There are some spherical balloons taped onto a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points, where points I is the pair x start x end, denotes a balloon whose horizontal diameter stretches between x start and x end. You do not know the exact y coordinates of the balloons. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x if x start is less than or equal to x is less than or equal to x end. In other words, even if the arrow grazes the balloon, let alone goes through it, we count that as a hit. There is no limit to the number of arrows that can be shot. A shot arrow keeps traveling up infinitely, bursting any balloons in its path. Given the array points, return the minimum number of arrows that must be shot to burst all balloons. So, the given example is 10, 16, 2, 8, 1, 6, 7, 12. We can burst these with 2 arrows. That's if we hit the 2, 8 and the 1, 6 together by shooting it, for example, 6. We could also shoot an example 4, I suppose, as long as we overlap both of those balloons. And then we can do the same with 10, 16, and 7, 12 by shooting anywhere between 10 and 12. So 11, for example. Here we need to do it 4 times because the arrows don't overlap, the balloons, don't overlap with each other at all. And here we can do it with 2 because these two are touching each other. And remember, we count just grazing a balloon as popping a balloon, and these 2 as well. So I think we can largely ignore all this balloon context, XY plane stuff, all that kind of thing. We have a line. We have a line and we have some intervals on that line, and we want to touch each interval. Yeah, we want to find a set of points that is in every interval such that set of points is as small as possible. I don't actually know how to do this, so nothing is immediately coming to mind, which is a bit of a problem. I don't even know how to guarantee we're going to have a minimum. Well, okay, no, I can use some meta knowledge here. This is a minimum, a medium problem. So it's probably not going to be anything horribly sophisticated. We can probably get away with a greedy algorithm here. So if I find all the overlaps, find the thing with the most overlaps, remove that, and all the points, then repeat. No. Okay, I think that would work, but that feels slow. Finding all the overlaps again and again and again doesn't feel reasonable. But do I need to do that? I know I need to hit every balloon. So for example, here I know there needs to be something between 10 and 16. These 2 don't overlap with that at all. And this one does. So that's fine. If I was to pick this one here, this overlaps with it, and that's the only thing that overlaps with it. So these 2 could be popped together. Is that it? No, there's... I'm a little bit jet lagged still. I'm getting better, but it's still waking up at 4 a.m. So my brain isn't quite working by the time 5 o'clock at night rolls around. Okay, hang on. So I have this brief sketch of an algorithm in my head. So what happens if we put these in order based on their start coordinate, for example? So we have 1, 6, 2, 8, 7, 12, 10, 16. If I'm at the first one, index 0, so I'm looking here, I want to go and find, I want to keep walking forward, finding all of the balloons that are have a start position less than 6. Is that correct? So I collect that one too. And then I'm done. And then here I want to do the same thing. I then remove these, and that's 1 arrow shot. And then I do the same thing again. I start here, I say, oh, hang on, this starts at 7 and goes through to 12, so I want to collect everything that ends before 12. So that's 2 arrows shot, and my list is empty. That seems to have worked. So this one will do everything up to 2. That works. This one will do everything with 3. That works. This will do everything with 6. That works. Okay, so this one here. This will do everything up to 2, so that gets collected. This will do everything up to... and then both of those disappear. Sorry, so this does everything up to 4. Oh, hang on. No, there's something funny happening with this end condition. What if I had 1, 6, 2, 4? Three, 7. No, this would collect everything up to 6. No, hang on. Let's put that at 5, 7. So if we do this one here, this collects everything up to starting at 6. No, hang on. Something funny is happening here. So this one here, if I fire a shot, so if I collect everything that goes up to 6, that would collect all of them and would suggest I can fire just 1 arrow. But that's not true, because 2, 3, 4, 5, 6, 7 do not overlap. I still need 3 arrows. So I don't want to collect up to 6. I initially think I'm going to collect up to 6, but then when I collect this one here, I'm actually only going to collect up to 3, and then I stop and I can shoot these 2. And the reason I need to stop is because I'm trying to collect as many overlapping balloons as possible, but that means I need to go to the... I need to remember where I started. No, this is always working. So I need to keep track of the minimum upper bound that I've seen. So here it's initially 6, and then it goes to 3, and I'm beyond that bound now, so I stop collecting. So those 2 disappear. That's 1 arrow shot. Then I do 4, 5, but that can't collect anything, so that's 2 arrows shot. Okay, hang on. So I want to keep this as a test case, I think. Let me just remove the spaces because I don't think those are necessary. So those there, I want to have a test case for 1, 6, 2, 3, 4, 5, 6, 7. I think that's an interesting test case to have. Now, how do I actually code that? Arrows equals 0. Return arrows. Points dot sort. And I think that just straight up works. So it'll sort by the first value and then by the second value, and that's exactly what I want. Okay. While points, in fact, no. While I is less than len points, I equals 0. Bound is going to be float inf. So I need to keep track of where I am and also the minimum bound I've seen so far. If points I 0 is less than or equal to bound is equal to the min of bound points I 1. So going back to this one with them sorted, let me just quickly write that out again. I shouldn't have got rid of it. This is 1, 6, 2, 8, 7, 12, 10, 16. So 1 is less than or equal to the bound, which is initially infinity. Then we say, okay, the bound is now 6. 2 is within that bound. It could be 8, but we'll keep it at 6. And then 7 is not in that bound. So what we want to do is we want to say arrows plus equals 1. I can now have shot that arrow to remove those two. Bound is equal to points I 1. Just immediately set it to be that. And then actually, oops. There. Then always increment. Oh, so this isn't a while loop, but it's for I in range len points. Suddenly seems rather straightforward. I'm a little bit suspicious here because this is working surprisingly well, if it's working. I don't need an I anymore. I'm suspicious. That came together surprisingly. Yeah, there's a problem. Oops, I don't have a colon there. That's a trivial problem. But for a problem I didn't know how to solve that came together surprisingly quickly, that's why it didn't work. Right, and then at the end, I need to fire one extra arrow. So I'm always going to fire one arrow at the end, so that I could equivalently do an arrow plus equals 1 at the end, or I can just start the count at 1. Is that true for all of these? Off by 1, off by 1, off by 1, off by 1. Well, you know the saying, the two hardest problems in computer science are cation validation, naming things, and off by 1 errors. So let's try that again. Lo and behold, it works. That's quite neat. This is a stack-like algorithm, I guess. No, it's not even a stack-like algorithm. This bound is working a little bit like a stack, but not quite. We don't even need a stack. I've never seen an algorithm quite like this, so I'm afraid I can't even give you a name on where to find algorithms like this to learn more about them, because I don't know if I've seen one before. Interesting. It would be some sort of interval optimization problem. Yeah, no, that's it. Fantastic. We're very much in the middle. I don't quite know what we've done wrong. We can probably... no, I don't know what we can do differently. Who knows? Maybe we just got unlucky on the runtime. Yeah. Woohoo! I think that's a good solution. It's fairly tidy. We could get rid of this infinite thing by starting our range probably at... Hang on. How do I go back to my code? Let's tweak this slightly. So bound can be 0.01, and then it's going to be from 1 upwards. So if we submit that, ooh, that didn't quite handle the edge case of an empty array, but I don't think we were given that. Okay, that's apparently even worse in terms of speed. I'm not quite sure what to make of that. If anything, that should be faster. So I suspect we're just playing around in implementation quirks or noise, effectively. Right, I think that will do it for today. I'm actually really happy with how that solution came together. When I read that question at the beginning, I thought I have no idea how to do this. Apparently I did. Anyway, do remember to like, comment, subscribe, all of that good stuff. Tell me how you did it. What was the solution that gets you down into this nice big section of efficient solutions? Anyway, I will see you next time. Bye.